This is CPM Calculus Chapter 3, number 76. So we want to compare the three different methods to find the derivative of f of x, which is defined as 2x cubed minus x. Okay, so we want to use the definition of a derivative for part A. So if we're given f of x is equal to this, we know that the definition of the derivative, or the slope function, right? Let's use the derivative f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h, right? So let's plug that in. So we have limit as h goes to 0. And what is f of x plus h? So f of x plus h, we just plug in for x plus h, right? So we have 2 times x plus h cubed minus x plus h, right? And then we subtract, so that's f of x plus h, subtract f of x. So subtract 2x cubed minus x, okay? And that's divided by h. Now if we plugged in h equals 0 right now, we would get something over 0. So we have to keep simplifying to see if we can get some ratio where h is not going to be in the denominator anymore. Okay? So let's simplify this. We have we still have the limit as h goes to 0 in front. The limit as h approaches 0, and we have 2 times, well, x plus h cubed is going to be x plus h times x plus h times x plus h, right? Minus x plus h minus, so let me distribute that negative, so this is going to be minus 2x cubed and then plus x over h. Okay, so the big thing in this problem is just distributing x plus h times x plus h, and then that times x plus h again. So x plus h times x plus h we know is just going to be x squared plus 2xh, because we have an xh here and an xh here, plus h squared. So let's go ahead and write that out. The limit as h goes to 0. Always write this until we actually plug in h is 0. So we have 2. Well, now we just did x plus h times x plus h. So that's going to be x squared plus 2xh plus h squared, right? Times x plus h. Let me simplify this, so let's distribute the negative here. Minus x minus h minus 2x cubed plus x all over h. Okay? So again, we have to multiply this times x plus h. So we have, let's use the box method again. Okay, so we have x plus h times x squared plus 2xh plus h squared. So x times x squared is x cubed, 2x squared h, x squared. Here we have x squared h, 2xh squared, and h cubed. Okay? So that's equal to the limit as h approaches 0 of 2 times, now we have all of this. So we have x cubed plus 2x squared h, right? But there's another one here, so that's 3x squared h plus xh squared, and we have 2 here, so plus 3xh squared plus, and then this is h cubed, right? So that's these two terms being multiplied. Minus x minus h minus 2x cubed plus x. Well, this negative x and this x cancel out, so we just have minus h minus 2x cubed, right? All over h. So a lot of the derivative using the definition to find it is just a lot of algebra and simplifying. So that's equal to the limit as h approaches 0. Now let's distribute that 2 all the way across, right? So that's 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed, right? That's distributing the 2, minus h minus 2x cubed, all over h. Okay, so again, we still say the limit is h goes to 0. And then, can we cancel any terms? Well, I see 2x cubed here and negative 2x cubed, right? And that's it, right? So then I have 6x squared h plus 6x h squared plus 2h cubed minus h divided by h. Well, if you notice, every term in the numerator has an h, so we can factor an h out. So that's the limit as the h approaches 0. I know it gets tiring rewriting this, and sometimes you'll forget, but you need to keep writing it. So let's factor out an h in the numerator. So we have 6x squared plus 6xh plus 2h squared minus 1 all over h. Right, and now we can cancel these h's, and we no longer have an h in the denominator. So now we're happy, right? 6x squared plus 6xh plus 2h squared minus 1. So now we can go ahead and plug in h equals 0 to see what the limit is, right? So then we have 6x squared plus 6x times 0 plus 2 times 0 squared minus 1. These terms become 0, so it's just 6x squared minus 1. And remember, on the left here, this is f prime of x, our derivative, right? That's our slope function. Okay, so that took a while, but that's good because we know that by the definition of the derivative, what our slope function is, 6x squared minus 1. Okay, so let's go ahead. We use the definition of the derivative. Let's go on to part B. Okay, so remember we just did this and we got 6x squared minus 1 using the definition of derivative. So using the power rule. So we look here, remember we bring the power down, so it's 3 times 2x squared, 3 minus 1, minus 1x to the 0. Simplify that, we get 6x squared, x to the 0 is 1, so minus 1. Do these answers agree? Well, yes they do, they're the same. Okay, so yes, they agree. Okay, so let's go on. As you can see, the power rule is a lot faster, right? If we have x to the power of whatever, the power rule is going to be much faster than the formal definition. Okay, so part C. For this part, we're going to use our graphing calculator. Graph the equation f prime of x is equal to f of x plus h minus f of x over h for a small h. So they're saying for h is 0.01. And does the graph match that of f of x from part A? F prime of x from part A. Remember that was, do you remember what it was? Just look here, we had 6x squared minus 1. So that's 6x squared minus 1 from part A. I'm just going to write that over here, right? Okay, so when we graph this, well, what is this going to be? So we're going to plug in h equals to 0.01. So that's x plus 0.01 minus f of x divided by 0.01, right? So let's plug that in to our equation here, f of x. So f of x plus 0.01 is 2 times x plus 0.01 cubed minus, remember, x plus 0.01, right? That's this right here, minus f of x, so minus 2x cubed minus x, divided by 0.01. So we plug this thing into our calculator. Okay, so I zoomed in my calculator. Let me turn it on. So I zoomed in, and now let me go ahead and graph this. Okay, so how do I plug this in? So in the numerator I have, let me open it with the parentheses. I have two, well, I can't really do this. It's zoomed too large. 2 times x plus 0.01 right? 2 times x plus 0.01 cubed minus x plus 0.01, right? So that's our first term minus, okay, so I closed this parentheses over here. So I want to add one more because I want to put all the numerator inside parentheses. So minus 2x cubed minus 1. So let me put that in parentheses. 2x cubed minus 1. Right? So closing the numerator parentheses divided by, and at the bottom, remember we have 0.01. 0.01. Okay? So let me put enter. And let's check, is this what we want to enter? 2 times x plus 0.01 cubed minus x minus 0.01 minus 2x cubed minus 1. Yes, all over 0.1. So let's go ahead and graph that. Busy. Okay, so I can see it goes down or something, right? So I believe we are already zoomed standard, but let me check. Right, so now I just see one line here. So let me zoom 2x cubed minus x. Well, let me put that one in because we want to see, are these the same, right? So let's go ahead. Well, what is this going to look like? Well, it's supposed to look like a parabola minus 1. So it's supposed to look like 6x squared minus 1, right? That's what we're checking out. That's what we're comparing it to. So let's graph both of these together. Okay, so that looks like what I expect. Okay, so why am I not getting that? Let me see. Do I have the function defined right? 2x plus 0.01 cubed minus x 0.01 minus, right? Okay, yes. Oh, this shouldn't be 1 right here. It should be x. 2x cubed minus x. Okay, so let me go fix that in my function. Maybe you didn't make this mistake, so you're like, oh, what's going on, right? Now it's looking like it should, okay? In fact, we don't see anything different because they're on top of each other, right? Because they do. Does the graph match that from part A? Yes, right? Well, how can we know that for sure? Well, let's go back to our y equals, and in our calculator we can change the style, right? If we go up to F6, let's make our this one appear. It's just gonna make it appear thicker, right? And let's make this one appear like a dot. Okay. Now let's go ahead and graph these. So that's good, right? Oh, well, the thing is, okay, we have to do it in the opposite order because making the first one really thick means the dot you can't even see. So let's go ahead and make this one the dot because it's going to be first, right? And then the second one thick. So then we'll be able to see it draw the first one and then the second one right on top of it. Okay, so here we have f prime of x defined this way using 0.01, and in the second one we have the slope function using the derivative definition or the power rule, and we're comparing the two. Okay, so first time, okay, I see the dot, right? Those are the dots, right? And then my my function here I got goes over it. All right, another way I can do that is since I'm making it thick the second time, I can just go ahead and use a regular line the first time. Okay, I'm just showing you how you can use this in your calculator. So the first time, the first y1 is just going to be a line. So there you go. And y2 is now thicker and is going to go over it. Okay, so there we saw it. So we used our graphing calculator. It matches. Yes, it matches. We're happy with that. We plug this in. Remember to make this an x, not a 1 like I did the first time. Alright, so this is the end of CPM Calculus Chapter 3, number 76.